Hey guys, this is your second instructional video for this week. So these two topics, your first one was slope fields, and the second one, this topic is finding or verifying solutions to a differential equation. So they're all kind of tied under this differential equation arch, but they're very different ideas. This is going to feel more like last week's instruction. Okay, and it's kind of just a lot of problem solving, going with what information you have and working it out and seeing what we can figure out from there. So this problem right now I'm going to put up for you guys. There is a lot of writing, so I'll kind of pause. If you don't have enough time to read through it, remember that this is a video and you can pause it. So here we go. Make sure everybody can see that. Okay, and this is supposed to be 1, 2. Oops. Alright, so I'm going to read it out loud. Here we go. A curve has a slope 2x plus 3 at each point xy on the curve. Which of the following is an equation for this curve if it passes through 1, 2? So we're going to want to pick out the important piece of information. Hopefully if you're doing this with me, you have your piece of paper out and you're already taking notes with what is important in this problem for us, okay? So right off the bat, I see this equation here, and I see this word slope. And in calculus, we remember that when we see that word slope, that should trigger something in our brains to say, hey, that means derivative. So I can say, hey, if the slope is 2x plus 3, I know that dy dx equals 2x plus 3. Or if you're not comfortable with that notation, you can say y prime equals 2x plus 3. These are the same thing. Okay, but you should be comfortable with both, right? The second piece of information that we have is this point. We know that it's going to pass through the point 1, 2. And this is an initial condition for a differential equation. This is going through the actual function itself. So when given a multiple choice situation like this, we're going to use that point and kind of see if it works in all of our possibilities here. So I'm going to plug in that x and y and see which functions that holds true for. So here, 2 equals 5 times 1 minus 3. I just plugged in my x, plugged in my y, and we're seeing if it works. So 5 minus 3, that's 2. Yep, that does work. So A is okay so far. Let's try B. I have 2 equals 1 squared plus 1. Well, that's just 1 plus 1, which is 2. So, yep, B is okay as well. And again, if I'm going too fast, remember this is a video, you can pause it. C, I have 2 equals 1 squared plus 3 times 1. So this would end up being 1 plus 3, which that is not 2. So I know that C is not going to be my answer here. I can eliminate that option. All right, so then let's look at D. Y equals x squared plus 3x minus 2. So I'm going to do 2 equals x squared plus 3x minus 2. And this time I have 2 equals 1 squared, which is just 1, plus 3, which is 4, minus 2. Hey, that is 2. So that does work for us as well. And our last one, 2 equals 2 times 1 squared plus 3 times 1 minus 3. Okay, so 2 plus 3 is 5, minus 3 is 2, so that one works as well. All right, so we did eliminate one option. That's good for us. So that was what that one piece of information helped us find. Ideally, we'd like to figure out more. But remember that our function that we choose has to fit 2 pieces of information. It not only has to pass through this point, it also has to have a slope or a derivative of this. So we know that these 4 options, A, B, D, and E, pass through this point 1, 2. We need to now figure out which of these 4 also has a derivative of 2x plus 3. So let's look. My derivative of y equals 5x minus 3. If I take the derivative of that, I'm going to get dy dx equals 5. That is not what I want, so A can be eliminated. Okay, let's go to B. Let's see if it has that derivative of 2x plus 3. So B, if I take my derivative, I'm going to get dy dx equals 2x. That's it. Still not what I want. We're closer. We got the 2x, just not the plus 3. So I can cross off B. And remember that when we did this way back when, we're saying, hey, I took the derivative of y with respect to x. If it helps you, you could put dx over dx here. We took the derivative of x with respect to x. But we said, once I write that, this really just ones out, so it goes away. All right, let's move on. C, we said no. Let's try D. So our derivative here, we get dy dx equals the derivative of x squared is 2x, the derivative of 3x is 3, and the derivative of negative 2 is 0. Hey, that's what we like to see. Now let's make sure that it's not e, because right now I'm thinking D is the one. So e, if we take the derivative there, dy dx equals, we're going to get 2x squared, our derivative there would be 4x. So I was correct in my assumption. D is our correct answer there. Because it fit all of the conditions for our differential equation. Okay, now I know that our exam is not going to be multiple choice. However, there could be something along the lines of like, verify that this is a solution, or in our next example, you're going to see you're finding a constant that makes it true. So we won't necessarily have a problem that looks exactly like the one we just did, but we're going to use the same skills, and I wanted to kind of get our feet wet a little bit before we jumped right in. Okay, so let's look at example 2. Here we go. And I'll let you guys read that for a minute. Let me make sure you got it lined up. All right, if you didn't get a chance to read it, there is a pause button, but we are going to dive right in. Here we go. I don't know why I put the lid back on. It says, for what values of k, if any, is y equals e to the negative 2x plus k e to the 4x a solution to the differential equation y minus y double prime over 4 equals 5e to the 4x. Okay, so here we go. This is going to be a fun one. Now, let's start off with what this is asking us. K or C in calculus are our descriptions of a constant or just some number. So I want to know what number would I have to plug into this equation, our original equation, for it to fit this property. Okay, and this is our kind of differential equation with all those x's and our y's tied together. You'll notice that we do have a y double prime. So let's just right off the bat start by finding, I need to know what the heck y double prime is. Okay, that's our second derivative. So let's take our original equation and find the second derivative. Okay, so here's our original equation. Now keep in mind as we're going through this, you'll notice right off the bat we have an e to the u. So we're going to have to use the chain rule here. And remember that the chain rule says we do f prime of u times u prime. Okay, so when I'm taking our first derivative, okay, I'm going to have y prime equals, this is our e to the u, and we remember that e to some value, that's our special function in calculus, it stays the same, but we do have to multiply it by the derivative of our u. So we're going to have negative 2 e to our u, negative 2x. Okay, and I just use that chain rule there. If it helps you, this is the same as e to the, I did it like, e to the negative 2x, that's our f prime of u, times our u prime, which is just negative 2. And then in my head, I just simplified them to that. Okay, plus, and remember that k is just some number, so I'm going to treat it just like some number. I'm going to do the same thing, use my chain rule with that 4x. So I'm going to get 4k e to the 4x. Oh, that's next, not a k. Okay, my k stayed out front, it's just a constant, and I multiplied by 4 because that's my chain rule. Okay, now we don't just need y prime, I need y double prime, so let's do it again. So y double prime equals, now I'm going to do this again. Remember, I have to multiply by our derivative of u. So now negative 2 times 2, I'm going to get a positive 4 e to the negative 2x. And then multiply these together, I get plus 16 k e to the 4x. Let you guys look at that for a minute. Okay, so now I have some more information that I needed. Now I'm going to actually, I know this is going to seem very cumbersome and long, I'm going to actually fill in, substitute in what I need to substitute. This was our original function, and this is the second derivative that we just found. So let's get to writing. Here we go. So I'm going to have y, which was this, so e to the negative 2x plus k e to the 4x. That's my y. I'm using this, substituting it in. Minus my y double prime, and I'm going to kind of box these off so we aren't tempted to solve or do anything weird with them. We're going to use this one. Minus y double prime, so 4e to the negative 2x plus 16e to the 4x, all divided by 4, equals 5e to the 4x. Whew. Okay, so hopefully you guys are with me. If you have gotten lost, forgotten what we're trying to even do here, we're trying to figure out what this k value needs to be. Okay, now before we go through and do that, I'm going to simplify this a little bit. Hopefully you guys are wanting to deal with this fraction here. So I'm going to divide each coefficient by 4, and that gives me e to the negative 2x plus k e to the 4x minus 4 divided by 4 is just 1, so e to the negative 2x, there's our invisible one, plus 4, or sorry, this is a minus 4 e to the 4x. Okay, and we want it to be equal to 5e to the 4x. Okay, now hopefully you guys are seeing what I'm seeing. Hey, look, we have opposites here. I have a positive e to the 2x and a negative e to the negative 2x, so those can go away. And because these have the same exponent, these are actually like terms. Oh, I'm missing a k here. Oops. You guys were probably freaking out. I just forgot to copy the k. Okay, so let me write that a little bit better. 4k e. Okay, so when I combine these, remember this is really just a 1k. So 1k minus 4k, I'm going to have negative 3k e to the 4x equals 5 e to the 4x. Okay, since this e to the 4x is on both sides, goodbye. Now I have negative 3k equals 5. So I know in order for all of this to be true, in order for the differential equation to fit this property up here that we started with, and use this function, my k value will need to equal negative 5/3. Okay, so we started off finding the information that we needed to find out. Then we plugged it into our given condition here. We know this is what it needs to be. And then we solved for that constant or the k value. Okay, so this is mostly what your assignment is going to look like. I just have a few reminders for you guys as you're doing that. So, my few reminders. Okay, remember the chain rule. If you forget the chain rule, it will get you into trouble. Okay, so real quick example of our chain rule. Let's say we have tangent of 2x. This would be tangent of u. And our u is 2x. So this is our f of u. So our f prime of u would be, and that's just the derivative of tangent, would be secant squared u. And our u prime would be 2. So our derivative of this, we're going to multiply these two together, and I'm going to get, sorry, I'm running out of room, secant squared u times 2. Fill in that blank, or that u, and I have secant squared 2x times 2. And most of the time, this 2 will be kind of moved up to the front just because it's prettier. So our final answer here would be, 2 secant squared 2x. Should have given myself more room there. All right. And then you're going to see on number 9 that you're given multiple equations to check. And if that is the case, like you're given a Roman numeral 1, 2, and 3, if that is the case, you need to check all of those equations. Okay, so number 9 on your homework is going to be a little bit lengthier of a problem, but I'm sure you guys can handle it. Right? Again, as always, if you have questions, reach out, let me know. I am more than happy to help. All right, have a wonderful week, you guys, and good luck.